Just, I can see it coming in through your mixer. Just make sure you have that selected in your.
Expectations. Maybe just API, like server-side API. Server-side API. Okay, server-side blockchain. Thank you. Yes. Remind me of the hazard here. And common accord.
Yeah, basically. And also, like in your list, there were 2 people.
They're not here. They're not here.
So maybe we need to call them out. Did you have you already come up here or not?
No. Yeah.
So, is there anyone else who wanted to give a lightning talk, kitchen sink talk, or any other kind of talk and did not come up yet? Then Tom.
Thank you. Awesome. Thank you. No, I was just making sure you had a connector.
Yeah, we have HDMI, VGA, dongle.
Beautiful.
All right, excellent.
So you will our future.
You can introduce your thing. We'll just introduce you. We're fake art now. Yeah. I keep this on. What is this question? What was the other? Was there something else? Yeah. You can do this. Okay.
Jeff? What's your 35 seconds?
I'm just going to mention that patents can be used to sue anybody in that Verizon and Bank of America.
So I'll let.
I mean, if that's not,
No, that's fine. That's fine. What is so? Give me the title. The title. Bitcoin patent, okay, or blockchain patent.
Yeah.
That's a pretty broad. Well, no, but what I'm saying is too broad too. Yeah. Unless, yeah. You know what? We're gonna actually have an exercise. Yeah, I totally get it. And you can also, because it's not regular, you can also just stand up and say, hey, I just talking about that. Great, thanks. 14 people. Yeah. So how do we, yeah, let's get started.
Okay, everybody. Now I need everyone. Hello, it's me again. The girl in Bitcoin dress. Hi. If that, no, everyone, I want to know, everyone to note, I have a Bitcoin dress. Like.
Do you want to give a lightning talk about that?
Oh, absolutely. So I need everyone to have a cup of coffee or tea or beverage of choice, because we'll be sitting here till lunch and listening to lightning talks and discussing things, okay? So be prepared for that. And I need your laptop, Doug, because I'll be introducing people. So first, I will, well...
Actually, we didn't sort them by order.
Yes. First person to give a talk will be...
Thaddeus.
Yeah, I'm just deciding.
How about Tariq?
Tariq. Yeah. Okay, Tariq and blockchain receipts. Stand up, come here, and give us 5 minutes. Well, too bad. You're last and first out.
This one?
We'll go fine.
I should be able to.
We're going to try to limit them to 3 to 4 minutes for every. Oh, sorry.
We're going to try to limit the lightning talks to 3 to 4 minutes for everyone, unless you really need the time, just because we don't want to use up too much more time.
Okay, thank you. I'm Tariq. I'm the founder and CTO of a company called HashCloud. We are based in Sydney, Australia, with our development lab in Malaysia. So I will straight away go to the point. So what we are doing, we are trying to create sort of like an Internet of services. So we define the service as being a service is produced and delivered by collecting and processing data or documents from the service applicant. Okay, so it is always like either you are taking my IDs and you are taking some data from me to give the service back to me. So now I am Tariq. Whatever service I need, I will always be serviced. So what we are trying to solve is that if I go to a bank and do a KYC, so the bank does the KYC for me. So I go to a second bank, that second bank again do a KYC for me. So but the point is like I am Tariq. So if we create a sort of like a hub where I put all the service like objects, which we call the service data objects or service document objects, and we create the hash of those data and documents and put it into a blockchain. So then anybody can verify that. So that is where we are coming from. So then the customer if the customer goes to an embassy to apply for a visa, the embassy again asks for, like, give me your passport, give me your identifications, give me your educational details, everything. So again, the customer has to copy those documents and give back to the embassy for them to deliver the service, which is giving them the visa. So again, so what we are trying to do is that why can't we centralize everything so that the customer can apply for all kinds of service through the same portal. So that is the portal that we are trying to sort of build, and we are going to very soon we are going to have some clients, but the problem comes. So the problem comes, like, now the customers, my initial customers may decide to go through me to validate, to put their certificates, to cryptographically hash their, like, educational certificates. Like if I go to a university, they give me their certificates, we hash them and we put it into blockchain. So we use a company called Ethereum, and then Ethereum gives me a receipt, and they use blockchain, Bitcoin's blockchain. But the problem is, if I go to another university and that university wants to put their certificates directly into whatever the blockchain they decide to put, so I don't know, like, what my customers, my end customers how will they verify if the receipt given to me or to my customer is different to what we are using. So what we are trying to do is that if we could standardize the blockchain receipts wherever it comes from. So we know that there are a few blockchains now, and there will be probably hundreds of other blockchains in the future, in the next 10, 20 years. So we still don't know, but what we're trying to solve, and there will be also other middle player who will be sort of like a middleware, like company called Ethereum. So we can go through them. So the application vendors can also go through them to put into whatever blockchain that we decide to use. So that means that there could be a plethora of different like standardized formats of blockchain receipts. So what we are trying to do is that why can't we have a receipt that is standardized across the net, and so that vendors like us it will make our lives easier. So what we are asking is to have a standardized blockchain receipt, and this is one sample receipt that we use, and that is from Ethereum. So that's about my lightning talk. Thank you.
Great, thank you. Can you? Okay, we'll do that at the end.
Let's do it now.
Okay, Arno and Hyperledger project now.
Hello, good morning, everyone. So I'm Arno Ross from IBM. I'm part of the Open Technology Group, and I'm actually involved in the W3C. I'm the main rep for IBM at W3C. I have a long history with W3C, but I'm also involved in the Hyperledger project, and this is what I want to talk about today. I mean, we've heard references to this project several times, and I wanted to give you a little bit more insight as to what's going on. The project is actually hosted by the Linux Foundation. I don't have any slides, by the way, in case you haven't noticed. But if you go to hyperledger.org, you will find the website, and everything is starting from there. You can find everything. So the project is started. It was launched officially, announced in the fall last year, and things really kicked in at the beginning of the year. This is open to everyone. You can participate for free. And so there is really no barrier to entry. You can also become a paid member, and a paying member, you get some specific privileges. You have additional benefits such as marketing and reserves, board seats, stuff like that. But so essentially, I mean, the project kicked off really quickly. It's gained a lot of momentum. We have attracted a lot of people. And as a technician, for me, it's kind of interesting because it's a different world where we have, people from legal, from from the finance industry mixing in with a bunch of techies. And it's kind of interesting from that point of view. But so we have a lot of companies from financial industry like JP Morgan, Chase, and whatnot. But we also have people from the tech industry like IBM and others. And so the project has a fairly ambitious goal of creating a framework which is very flexible and pluggable. And it's not a specific network. It's really, the idea is to develop a framework that you can take and use and configure to your own needs for your own application. And the big vision is that eventually we're not going to have one network of blockchain, but you're going to have like thousands of blockchain networks based on your specific needs for your own application. And a lot of them might actually be private blockchains. That's a big difference between other projects that are more like Bitcoin oriented, which are permissionless networks. In the enterprise setting, a lot of the applications can reuse some of the characteristics that make blockchain interesting, but because they know the entities they're working with, they don't have to have the burden of this proof of work, which is very expensive and which limits the throughput, the number of transactions you can have per second. And so a big part of the project is actually to address the need for permissioned network where you actually know the parties you're dealing with. And so the work is taking place at two different levels. There is a high level where there are projects, working groups working on things like the architecture at a high level, use case and requirements. There is a group on identity. There are several groups like this. And then there are different projects that are actually working on code. And so there are currently two projects in incubation. One is called Fabric, and it's based on a contribution from IBM and Digital Asset Holding. And then there's another one called Sawtooth Lake that was contributed by Intel. And so the first one is actually permission network. The second one is permissionless network. And so it's very easy to start participating. And so one more thing I wanted to say is, to the Hyperledger project actually submitted a position paper for the workshop, because the workshop is about, should the W3C do anything in standardization? If anything, what? And so the vision of the position from the Hyperledger project, to tell you the truth, it was not very easy to define because it's already a big organization. And so when you have a lot of people, they have different positions, trying to agree on what the position of the whole project is a bit of a challenge. But essentially, there is a general agreement that it's too early for the most part to work on standardization because we're still very much in an exploration phase, and we don't want to start freezing things when we want different efforts that are underway to actually have the freedom of exploring as much as they want. In general, what we are also interested is if there is any standardization effort that takes place, it should be really modular and focus on very small aspects that can be combined, because again, the picture we have is this framework of pluggable components, which consensus you use and etc. It should be completely independent. And so again, the position is it's kind of too early, and if things are done, they shouldn't be like wholesome, like trying to standardize the whole framework or the whole stack, but instead focus on small items. Thank you.
Thank you. Okay, next.
Hello? Okay, great. So what I want to talk about, I just have 3 minutes, is this thing that's called TMSP, but we might change that to be SB API. And the point is that it's splitting the blockchain into two components, right? Kind of like what Hyperledger, IBM Hyperledger is doing with chain code, except this is a bit different. In chain code, only the logic resides in the application. Whereas in TMSP, soon to be renamed, the state storage mechanics is on the application. So you can use any patricia tree that you want or not. You can do whatever you want. The point is that Tendermint is just a consensus engine. And once the blocks are committed, it pushes the transactions to the application using something like CGI. Anyways, you can kind of see, if you go to GitHub, Tendermint/TMSP, you can, the README, you can see some of the messages. So like append_tx is a message type that gets pushed to the application after it's been committed, and there will be one of these messages for every transaction in the block. And when you commit, then the application returns like a Merkle root hash, which gets put back into the blockchain on the Tendermint side. Now you can do Merkle proofs and so on. So there's now also gRPC support for this. So if you want to just write your application and support gRPC, that's also possible. Or you can use the network socket version, which is way faster. It allows you to push transactions asynchronously. So if you want to talk more about this, join our Slack. If you go to tendermint.com, you'll find our Slack channel. We're always adding more things to support. So if you need anything, the benefit of this, the benefit is that you get to develop your application consensus agnostically so that you can plug in any kind of middleware that you want. Right now it's only Tendermint, but presumably other people can develop their own middleware. Thank you.
Okay, great. Thank you so much for being brief. Next will be a talk on Lightning networks.
Thaddeus.
Thaddeus.
Oh, okay, works. Hi, let me get this displaying, hopefully. Oh, it's too. It's a different resolution. Well, let's see. Is this visible? Anyway, okay. So I'm going to talk about scalability and blockchain. Blockchain scalability using payment channel networks. I'm working on something called the Lightning Network. It's currently being built in Bitcoin, but it can support other things. And so one of the fundamental problems with blockchains that I think people recognize is scalability, right? How can you work with millions of users? How can you have rapid interchain transactions, things like that? And the problem is that, the blockchain fundamentally is shared. It's, you can call it a distributed ledger, but it's really a duplicated ledger. And everyone has the same copy of everything, which is pretty inefficient. It's sort of like, although there's really good internet here, so it's not a good example. But, when you're in a conference and everyone's using the same Wi-Fi AP, it's usually kind of slow. And you can increase the speed of the Wi-Fi AP by going to, 802.11 and AC, whatever. But really, you want a segmented network. You want to have everyone plugged into their own switch. And that's how to really scale networks. So it's a trade-off, right? Global consensus is important, but inefficient. So how do you do this? How do you segment the network without losing these properties of the blockchain? And the way to do it is with payment channels. And there's you can make networks out of payment channels. So this, hopefully, it's not quite a cryptographic primitive yet, but hopefully it will be so widely used that everyone will consider it like an obvious primitive in a few months or maybe years. So the way it works is you send, in the case of Bitcoin, you send, let's say, a Bitcoin to a shared multi-sig address, and then you can exchange signatures which lay claim to the coins in that address. And this happens offline, or off the blockchain. So we can keep sending these messages back and forth. And that alone is pretty complicated. And if I can't, I don't have time to go into how it all works, but it's pretty cool. And then that allows you to establish channels where I send one output to the blockchain, and that's a channel, and we can move money back and forth between two parties. That's kind of useful, but for payments, you can't just have one person you're always paying, because most payments are not metered. If you're connecting to websites, you're not going to the same website every time. So how do you extend these channels to other cases? And so this is the sort of fundamental way the Lightning Network works. You can kind of see. Oh, you're not going to be able to see it. Shoot. Let's see. Hold on. There. Good enough. Okay, so the way it works cryptographically is Alice has a channel with Bob, who has a channel with Carol, who has a channel with Dave. Alice wants to send a payment to Dave without opening a new channel, because that incurs the blockchain cost of having an actual output on the blockchain. So Alice and Dave communicate over the internet, and okay, so Dave creates a random number R. It's a nonce basically, hashes it. So now you have hash H, gives the hash to Alice. Alice then says to Bob, hey, I will pay you contingent on knowledge of the pre-image of this hash, right? So Bob, if you know R, you get a Bitcoin. And Bob does not know R, only Dave knows R. So Bob says, hey, Carol, I'll give you a Bitcoin if you know R, and Carol does not know R. So Carol says to Dave, hey, Dave, I'll give you a Bitcoin if you know R. Dave does know R. There we go. Okay, so and then the R backpropagates, and it all works, and it's really cool. And this is a sort of network infrastructure I think a lot of blockchains will use. And yeah, hopefully if you want to learn more about it, ask me questions after. Okay, thanks.
That was an amazing wrap-up, seriously. Okay, Evan, I know that you just arrived, but please come up and talk about Interledger. Thank you so much.
And also introduce yourself when you, because we're just getting first names.
I'm Evan Schwartz. I work on Interledger, and I literally just got off the plane, so sorry for being late. So Interledger is thank you. So as I said, Evan Schwartz. I work on Interledger, which is a protocol for cross-blockchain or cross-ledger interoperability. So everybody's here because in some way or another, we believe that distributed ledgers are better than these kind of siloed or hub and spoke networks. So everybody's got their own flavor of blockchain that they prefer. What we don't want to do is recreate the silos that exist today, where everybody has their own blockchain for their own use case, and there's no interoperability between them. So what Interledger is a protocol for transferring assets across different ledgers. And this is specifically for transferring assets, but this could be fungible assets like currency or non-fungible assets like names, titles, deeds, etc. Basically, Interledger is inspired by the design of the internet, because what the internet fundamentally is about is connecting different networks together. It was not about getting everyone on one single giant network. It was about connecting completely different networks using a very simple protocol. So the internet is based off, the fundamental building block of the internet is addressing. It just has this simple address format, and then you have gateways which route between different networks. Interledger works basically the same way, where you have an address and an amount. This is the very fundamental piece of Interledger. So you have a way to address some account on a distant ledger, and then it's basically like putting an address on a little envelope. So you're on one blockchain or ledger. You address your little envelope with an amount and an address. There's these connectors, which are basically like internet gateways that route money or assets between different ledgers, and then it gets to the recipient. And what you can create with that is you can create very long chains so that anybody can pay absolutely anybody, no matter what ledger you're on. And the idea is that you could be on Bitcoin and I could be on something completely different, and we could still transact just fine. If you're interested in learning more or how all of that actually works under the hood, come talk to me or check it out at interledger.org. Thank you.
Sorry, really quick question. Were those MIME types?
What's that?
Was that a MIME type?
That was me in an airport at 11 p.m.
Thank you. So, of course, after, I mean, all of these lightning talks are to start the discussion, and we'll have, as yesterday, discussion tables afterwards. and I'm sorry if I'm pronouncing your name badly.
And while he's getting set up, so we're going to have 2 more lightning talks, then we're going to take a brief break, and then we're going to start back with lightning talks again.
Okay, so I'll just talk about the security issues and how we trust that blockchain technology. So I'm Shinichiro Matsuo, and BSEF Network and chair of the MIT Media Lab. So this is also here from that the conversation startup yesterday. So the problem is how can we trust the output from the blockchain technology? So this is a problem. And so we had several security issues in blockchain. For example, so we had a huge DAO attack problem 2 weeks ago. And so this is caused by the vulnerability. This is an implementation issue. We also have other issues in the protocol level or implementation level or operation level in the blockchain technology. For example, that we do not have concrete verification of the protocol specification, and we do not have the sufficient key management mechanism, including lifecycle renewal, revocation of keys. So we should check that implementation of the code, and so we should have this fine-grained operation and this vulnerability handling. So this is the security layers. This is not specific to blockchain. This is a general thing for crypto-based systems. We should have a security evaluation for cryptography, and we should verify the correctness of protocols. We should check that correctness of implementation. We should have the fine-grained rule of operation. We already have several international standards on each layer. But so my understanding that we do not have such kind of fine-grained security layers in Bitcoin and blockchain, and we need them for blockchain, and more research are needed here. At this time, to do such kind of research and other kind of research to mature the blockchain technology enough, I and Pinda Wong already started the project named bsafe.network. This is a NSF net for blockchain technology. This is a neutral, stable, and sustainable research test network for blockchain technology by international universities. Each university researchers become a blockchain node here, and so university researchers conduct research on blockchain and its application. So the topic of the research is not limited to the security, and all aspects of the blockchain technology it can be tested over this network. This is a neutral platform and trust anchor of the blockchain network, and so we can have more nodes with neutrality, and this is a test bed for academic research. So we already started this project, and this year is a bootstrapping phase. We already started attacking the Bitcoin and segregated witness protocol, and we will add some more protocol like Ethereum, Hyperledger, and others this year. And next year, we will make the scope of research wider with funding. And from the W3C viewpoint, we should have many standardization items, including ontology, analysis framework, use technology, operational environmental policy interface, message format protocol, and relationship with existing standard in the W3C. We should discuss about organization of keeping security, including a collaboration with other standardization organization and group of experts, and communication with academia. Thank you.
Okay, great. Thank you so much. Next, we'll have a talk about expectations about Web Crypto API from Shigeru-san.
Thank you for introduction. And my name is Shigeru Fujimura I'm a research engineer at NTT Corporation from Japan. My research topics is applications that takes advantage of blockchain, especially blockchain-based content distribution. Our main target is video contents. And this is a panel of our exhibition of NTT Laboratories Open House at February in this year. At that exhibition, we showed the prototype demo system for content distribution system. And this system has two functions. One is, it's like yesterday's discussion about the provenance. One is the contents registration method to blockchain. It's like a proof of ownership and proof of metadata authenticity. And second function is video play control. It's like DRM, and we use in that function decrypting encrypted media using media source extensions and cryptography API. These are part of broad sense, HTML5 in broad sense. Today, we showed that this prototype demo system at lunchtime and after events at the left side of the desk. And we would be happy if you could see our demo and give us a comment or opinions. And anyway, this is this is my point. Through the development of our demo system, we have many impressions. That is, regarding Web Crypto API, its implementation depends on browsers. For example, some browsers need HTTPS connection. It means for developing phase, in the developing phase, we have to get the SSL certificate. It makes developing more hard, I think, more difficult, I think. And second example is implemented crypto algorithms depend on browsers. Not all the crypto algorithms implemented in some browsers. That means, in conclusion, of course I know, Web Crypto API is in the process of W3C recommendation, and not yet W3C Web Crypto API is W3C recommendation. Of course I know, but all engineers would be happy if the Web Crypto API become a W3C recommendation, and all implementation in browsers are same. And that's my point. Thank you.
Thank you. So we're going to take about 10-minute break, and I think there should be some break materials there. And just in case it wasn't clear, they're going to be doing a demo this afternoon around 3:30 over there. And actually, would you guys give another hand to NTT for making all of this possible? And also to Media Lab, our other major sponsor, and Blockstream. Oh, personified by Sandy Pentland.
Our benefactor for the room.
Okay. We'll reconvene in 10 minutes or less if you have the will.
Yeah, so you're
I'm dropping you application in this area. So this area
I really, I don't want to talk about
is proof of work, which is very high cost and expense. So I like to choose another
We're already.
so I have
You can certainly stand up. So what we're going to do right now. How about
the post apply process for this area. Am I right? How to do that?
Yeah, so we don't have an implementation yet, but here, I'm going to show you. I might be able to find one. Let's see.
I said everybody who wanted to do a lightning talk. How about the process? But then click
Here it is, yeah. So, this is get, Ethereum get over TMSP. So, TMSP, we might rename it, like I was saying earlier. But the idea is that there's these messages. The most important ones are permanent, like the MTX. But the point of this is like this. Yeah. So it's a core. It's tenement core, right? So it's doing the consensus, and then if you plug in the get application at TNSP.
Oh.
Yeah. So get is now it doesn't have to talk to the outside internet. It only talks to tenement, but it's doing the computation of the state.
Does Get have the TMSP protocol?
No, it doesn't. So that's what this project is trying to do.
Yeah.
So it's Go. Do you know Go? Do you know how to use Go?
Correct. Yeah.
Yeah. So it imports get.
Yeah. Import.
And then it plugs into MSP.
I see.
You might be able to see it here. So yeah, it imports like TMSP server, which gives you most of the tools you need. But it also imports Go. Errors. This was errors for Ethan working on it. Hey, how's it going? Hey, good to see you again. Yeah. So server, which is imported from TMSP, makes it easy to create a TMSP application, and then you say listen on the socket, and then they created this application, and then Tendermint can talk to this, right? And it becomes a thing. But this is not complete. Ever since Ethan made this in February, Get changed. So this is broken, doesn't work. It's gonna, in order to make this work again, it'll take like a week. Okay? But we can help you because we're gonna do it anyway. What's your email?
Oh, it's like that.
Thank you.
My name.
What time is your
Yeah.
entity.co.japan. Okay. Is this right?
Watanabe is last name.
Oh.
Japanese name is last name past.
All right. Yeah, the same as Korean. We wanted to use Ethereum with Tendermint, and so we need to create an update to that. And
Also, if you go to
Thank you.
sure. Yeah. Let me know. Yeah, we can help you with that.
Yeah, I do that. Thank you very much.
Sure. Hey. Oh, thanks. Okay, thank you. How's it going? I'm a kind of this startup. Uh-huh. Uh-huh. See? Where are you at?
We're providing enterprise solutions. Oh, you can be Korean. And you.
Sorry.
Yeah.
Do you know Itaewon?
Oh yeah.
Bitcoin Center?
Oh yeah, I know.
Yeah.
Oh, have you been there?
Yeah, I was just there last week.
Oh.
Yeah, I was just walking around in Korea and I saw the Bitcoin Center.
Anyway, nice to meet you. Oh, could you give me some insight on the tendermint?
Sure.
Is it supposed to work with other blockchain implementations? Like you mentioned to me about the blockchain.
Yeah, it's not working now, but we
Yeah.
will make it work. It's probably the easiest way to
Yeah.
plug in BFT consensus
Yeah.
into anything like Bitcoin or whatever.
So it provides some kind of consensus and communication layer on top of EVM or even blockchain UTX state machine.
Yeah. So there's two communication layers here, right?
Yeah.
There's a server-side API. We call it TMSP right now.
Yeah.
But it connects Tendermint to the state machine.
Yeah.
The state machine doesn't have to be exposed to the internet. The other interface is through the Tendermint APIs.
Yeah.
So there's WebSocket APIs and gRPC soon
Yeah.
call Tendermint.
So it's supposed to provide a agentic tolerance and at lightning fast speed, right?
Yeah.
So what kind of optimizations or attendance protocol are you using?
Yeah.
Access app
We're using so Paxos and Raft are like fault tolerant, but they're not
Yeah.
Byzantine fault tolerant.
Yeah.
So we developed our own. It's very similar to PBFT, but arguably it's a bit simpler.
I see.
And we've been working on it for 2 years or so, but we finalized it last year. Wiki.
PBFT based on.
It's not
simpler
based on
means
PBFT.
Well, I think simpler means better because like in a way, Raft is better than Paxos because it's easier to implement.
Oh yeah, exactly. Right. So the problem with this is that we don't have a white paper yet, except just a wiki. So, but once we put it in white paper form, we believe that it'll over time gain more adoption than PBFT. PBFT is not even optimized for the blockchain. So Tendermint and this algorithm is really designed to be a blockchain, but it's got the same kind of primitives as PBFT. And here's like the algorithm.
Yeah.
And how it goes. There's also a white paper. We're going to launch a public blockchain nuclear. In this white paper, it goes a little more into things like this is like proof of stake stuff. So maybe you don't care.
Yeah. So Tendermint is the core and G-Nuclear is blockchain based.
Yes.
And
Absolutely.
Tendermint can be programmed to other blockchain implementations like Bitcoin.
Exactly. There you go.
So it could be like how B-tree implementations can be plugged into like MongoDB or databases.
Yeah, right. There's even actually now that you say it, there's even right. If you use, are you going to develop your own blockchain application?
Oh, actually, we are based on Bitcoin. And we're trying to expand.
Okay, everybody, sorry. End of break. Start sitting down. Europe? Nope, 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 nope. Okay, Mountie and blockchain community group. Come up and start talking. I see 2 people in the left corner chatting. Stop chatting. You, there. Okay. We're doing really great on time, guys, so I'm really proud of everyone. And we will be ready for lunch in time, I hope. So, kudos.
Hello, good morning.
Yeah, sure.
Okay, hello. My name is Mount Lee, and I'm from Paygate, Korea, and also working at the blockchain community group. So let me introduce the community group. So actually, blockchain community group is not the official W3C working group. There is the named like a community group. So we had a mission to generate message format standards of blockchain based on ISO 222 and to generate guidelines for usage of storage, including torrent, public, private side chains, and CDN. And also we are trying to study and evaluate new technologies related to the blockchain. We have started March and had a first workshop at the 25 March at Seoul, Korea. And currently we have the 53 participants, including Paygate, Broco, Gonggung University, Atri LG, Walt Disney, and Blockstream. Blockstream, I don't know, he will try to join at the Concord, and the chair is Nick Lee. So some activities we had is we are running the website and has a mailing list and telcon every Thursday, 11 p.m. KST. There is actually 7 a.m. EST. And also we are running the issue tracker. And we found many issues, reports or deliverers. And so trying to define message formats and data flow and the summarizing ISO 222 and the storage guidelines. We have talked about the public-private side chains and torrent and CDN, and also talked about the identity authentication and authorization, and also networks or use cases. And now we have selected the 2 proposals. One is blockchain authenticators and the centrality of a blockchain. So you present.
Yep. So one of the major problem with blockchain applications is that there's no existing robust way to manage keys for end users. And we took from the example of FIDO and its UAF implementation. Oh, okay. Yeah, and we could extend existing implementations and protocols to actually use it for blockchain. So existing blockchain applications and even end user apps can take advantage of FIDO authenticators, which are already preloaded on a bunch of devices and use it for blockchain instead. And we are already working with several FIDO providers to experiment with this idea and provide a robust implementation.
Yeah. And the third chain is a centrality of blockchain that is trying to use blockchain transactions as a relationship line between the blockchain addresses. So we are able to measure the centrality and with another three important elements, the size of amount and level of verifications, and measure the centrality of address. So that can be used for the scoring the credits of address. So there's missing and remainings. And so we found the mission is not matched to some participants. So please contribute the CG. Thank you.
Actually, hey guys, so we also had a conversation. I want to also establish what a community group is, in case you don't know what a W3C community group is. It's an open group that anyone can join, and you don't have to be a member of W3C to do that. And I talked with Mounty and him about maybe as part of the overall, like as part of this new interest in blockchain at W3C, maybe we can start expanding the blockchain community group. And so if you're interested in getting involved, then come talk to us, and we'll see. We're thinking about setting up little topic areas within that community group. And so it just might be a good way for us to carry the conversation forward.
So next will be Guri and IoT. Guri? And also for everyone who gave a lightning talk and will be giving one, I would ask you to be ready to have like a 5-word summary of what you want to talk about at your topic table, okay?
Awesome. Thank you. All right. We've been doing some work on proving the blockchain capability with an IoT use case. Many of you might have seen other presenters from my team, from our team, might have seen some of my other work at other events. So basically, I'm going to go quickly through 4 pieces of flow over here. One is, what is the problem that we went after? Second, certain uniquenesses about IoT, which otherwise could easily be forgotten in a non-IoT world. Third is the solution and the proof, and fourth is a little summary of some of the future considerations and open problems that we didn't complete so far. So as far as the problem and the challenge is concerned, everybody's seen a picture like this of a typical hierarchical, centralized IoT solution, tiered model, and in most cases, it's repurposed. It's repurposed from existing technologies. So in a sense, I think that's where the state of the art and the state of the possible, state of the art is right now. I shouldn't say state of the possible. The state of the possible is beyond that, and you'll see that glimpse in the solutioning portion of it. It's device-centric. It's not user-centric, right? So from those of you who are from the design thinking user experience world, this is very device-centric. I need an app. I need a control point for every device. And then if I've got 20 devices in my home, I need 20 apps potentially. It's highly centralized. And I caveat that by saying that's the only model, right? I'm not saying that centralized models don't have a place in the world, but you'll see a slide later where the notion is considered of a portfolio where there are certain places where they're centralized models, certain places where they're decentralized models and hybrid models. So when we look at this kind of a model, it's okay, you can repurpose technologies to new solutions up to a certain point, but then they become unsustainable from a scale and performance standpoint technically, but also unsustainable from a monetization, business monetization aspect, including privacy of data and all the things that we know have been a little invasive towards privacy. So if I step into the next portion, which is what are the uniquenesses around IoT, I think it's important to look at that. So we are looking now not at like millions of devices This is a scale that the planet has never considered before, right? So we're talking about tens of billions of devices. We're talking potentially of hundreds of billions of devices. So it's never been considered, computing has never been considered at the edges at such scale ever in our history. So the other uniqueness is about longevity. So if you think about longevity, we typically don't think about longevity the way we think about, we have to think about in the context of IoT. So if there is a solar roof in a house, that could have 50 years. Similarly, for appliances, typically have 10 years. All the life cycle implications and software implications around that. These devices are not always on. They're temporal and spatial movements and shifts that happen. By definition, in an IoT world, there's OEM heterogeneity, and you have to look at seamlessness. So what is the solution? What is the proof point? What is the proof that we've learned from some of the work that we've done? It's got to be user-centric. It's got to be sensory. Increasingly, it's got to be cognitive. Scale, of course, decentralized. The economics have to be sustainable. Monetization model has to be there. I won't dwell on this slide too much, but this is the portfolio model. And what we are looking at is, for decentralized solutions of IoT, we are looking at device longevity to be towards the high end and the device value towards the low and medium. So think about your devices in the home as a most common example. And if we land a blockchain footprint on these nodes, and of course, we got to worry about the footprint of the size of the blockchain, you basically begin to link these two worlds, right? And you have a network of devices which is on a distributed ledger. I'll skip some of this, but this is a proof point on a washer activity automatically generating a bid for technician services after going through warranty. But you're now looking at a blockchain, you're looking at assets being liquefied, they become shareable, different level of responsibilities, they're autonomous, so on and so forth. Let me just jump to summarizing the open considerations. We got to worry about what is small, what is medium, what is large. And I'll leave a couple of considerations over here about obfuscation of data, spatial and temporal considerations, and so forth. Okay? Thank you.
Thank you. This, I think, will be a very interesting topic table, and a lot of it will be covered. Okay, so now let's have James talking about Common Accord. And Daza, you're going to be up next. Okay, so you have 3 minutes to get prepared.
Hello, we up? Here we are. We're good. Okay. Common Accord is essentially how do you bring lawyers into the open source collaboration system. This slide, the little insert there is from Bart, who pointed out the problems of the non-contract nature of smart contracts from a prior conference that we did here. So how would you make them into actual contracts and more than contracts, all the complex contracts and the permits and actually everything that we now do through Word and other blob-based data formats? This is done with Thomas Harjano of Connection Science. The notion is that you can have objects and then you can essentially make connections. You can use blockchains and authorization control in order to create a secure, dry data system. The goal, my goal, is to create centers for decentralized law. They are essentially repos on GitHub that lawyers contribute to. Some of them will be of global impact. That is, some of the kinds of organization of formats of stuff has global impacts, and many problems are understood to be global, but anybody can create their own. Nations will want their own. The EU will want its own, and so forth. Concretely, we wrote a paper here for the conference, which you can see first part is about Common Accord. The second part is an intermediate layer of smart contract description language. There's a discussion group at Kantara. Thomas and I are the organizers of that discussion group. Pragmatically, what we do is we notice that with key values, you can do everything that lawyers do. So this is the form Y. This has the whole ecosystem in it. Y Combinator wants this stuff cleared up and made codified. 1 minute. You have a notion of identities, and you can point to law, and that gives you your whole text. So with that, we haven't created a new blob. Everything, this is a graph. Stuff is linked. It's up on GitHub, and students at French University have 3 young students have forked this thing and started their own repo of stuff in a French context. So what I'm looking for is people who want to connect with this ecosystem. How do we connect? How do we bring lawyers into open source? How do we bring their full knowledge? Instead of killing the legal system, why don't we make it efficient? Thank you.
Let's just kill it.
Thank you so much. Daza? So Daza will talk about URL for every block, and then Geoff will come up and talk a bit about blockchain patterns. Okay.
I wish I could use the blockchain, but when I point my browser at it, I don't see anything. That's a problem because I can't see anything when I point my browser at it. What would be great is if there was a URL that would allow me to find an address on a blockchain, find a blockchain and find an address on a blockchain and would render, actually, how about a hand for this guy? He's made everything happen. No idea how hard the sound is for the simulcast and everything and switching all these computers. Thank you. Anyhow, if I could just go and find a block because someone emailed me in effect a URL, I could use it. What's more is, well, fundamentally, I've felt for a long time, if, I think, therefore I am, I can browse it, therefore it exists. Like when an article or a paper or a poster, increasingly even like a policy is on a website and it goes to archive.org and I can sort of find it again and I can reference it and cite it with a PDF saying like, last downloaded on this date, that's real to me. When people email me stuff and things even happen in like so-called official legal books and other things, it feels out of channel, it feels out of sync, it does not feel particularly reliable, it feels, I'm not going to say broken, but let us just say anachronistic. And it's not usable and it's not addressable. It's not integratable. It cannot be part of the world that we're building into. So there's some connective tissue missing. And I think it's uniform resource locator. Just 2 things in the law. I foreshadowed one yesterday that would be possible if only we could find a protocol or some standard that would enable a URL to resolve to a block. Is statutes and regs. So Uniform Electronic Legal Materials Act already is been proposed to states. Some states have adopted it, others can, and it requires, like with 3 criteria, that electronic materials will be official. So it has to be, basically publicly verifiable, like an encrypted hash from the publisher, and broadly accessible. A blockchain is over sufficient to allow this to happen. So like we could have, another thing is we could have legal notices. So a car recall, what's the date of the election, just basic stuff. That could zero out a lot of costs when you get your consumer notices and when you want to know if someone's suing you maybe, or if you've got lost property. We can't address anything. Publishing stuff in newspapers is absurd. 1 minute. So I only got a little bit of the way through the slides, but what this one was gonna say is Well, let's just say the HML. So ultimately, we need to have a way that, with like elegantly, we can have machine readable, human readable, and lawyer readable resources. A URL to a per block absolutely can do that. And you can now reference like big fat Mongo legal documents. You could certainly reference the little human readable, like almost Creative Commons things, and it's all about machine readability, not just for the provenance. And it provides an opportunity to begin to integrate BLTs, not just delicious lunch sandwiches, but also business, legal, technical. I think the fundamental 3 layers that have to be aligned for true interoperability. Interoperability is not a technical alone. It's business interoperability, legal and technical. An address can get us there. Can we please have a URL for every block?
Thank you so much, Jeff. And next will be Christopher and smart contracts. So Christopher, smart signatures, sorry.
No, he's next. Hi, I'm Jeff, thanks. A patent is the legal right to prevent you from doing something. Doesn't matter if you independently invented it. If they have a government granted monopoly on it, they can legally prevent you from doing it and collect damages for the benefit that you gained from doing it. US Patent 9298806, System and Method for Analyzing Transactions in a Distributed Ledger. US Patent 9258307, Decentralized Electronic Transfer System. These are already issued patents, 2 of more than 50 patents that explicitly mention Bitcoin or blockchain. I didn't search on distributed ledger since that includes a lot of other things. There are at least 585 pending US applications, including, Reuters just reported last week, 50 patent applications filed by Craig Wright, the guy who recently claimed to be Satoshi. So there is a patent thicket coming that this community will run into soon. Now, the W3C has a patent policy. Entities that participate in standards groups have to promise to give their intellectual property in a royalty-free fashion, but that doesn't help if there are participants who aren't members of the W3C or members of that working group. So someone is going to need to do something. If you recall, about 5 years ago, a company called Lodsys claimed to have patents on in-app upgrades and in-app payments, and could have sued Apple, but didn't. Instead, sued all the individual makers of apps in the App Store. These are small startups. They didn't have the money to litigate. You may not actually be doing the invention. You may think the invention is invalid because of prior art, but it will cost you literally millions of dollars to settle that in actual litigation. So, I'm not going to claim that the coming patent thicket is going to stop blockchains or stop Bitcoin. That seems unlikely. But I think a lot of companies could probably go out of business or at least lose years of time to market unless the distributed community, I know it's hard for distributed communities sometimes to coordinate, unless we can also figure out how to coordinate to answer the intellectual property concerns that are coming. I think a lot of people are going to lose some money, and a lot of people who maybe you don't want to are going to make a lot of money. Thank you.
Thank you. Okay, so now Christopher and smart signatures, and then next up is Peter Todd with deterministic expressions.
Upside down.
Okay, so signatures are a 50-plus-year-old technology. I'm talking about the cryptography of it, the digital signature, okay? It is a hash of an object that has been encrypted by a private key and is verified with the public key against the hash of the object. All of our systems use this in a variety of complex ways at higher levels to either do identity or to sign a block or to do a variety of different types of things. The idea behind smarter signatures is, can we allow for more functionality. Multi-signatures, which is what Bitcoin and some other technologies have begun to allow us to do, is an example of this, but we'd like to address much more complex use cases. We also have to be very careful about it. This is very fundamental technology. We don't want to run into situations like the DAO, et cetera, that break things. We need to do some experimenting. Some of the possible uses, there's AND multi-factors, things like N of N multi-signatures, which do, like I said, exist in Bitcoin, M of N multi-signatures, but really some other possibilities are things like OR multi-factors. For instance, for legacy purposes, we could have an EC DSA multi-signature or the RSA multi-signature, or to really future-proof things, or a Sphinx hash signature, which is quantum resistance. So we could literally say, you choose whatever signature you want. We're giving you all three. Verify the one that works best for you. This allows for a lot of different kinds of varied content and different kinds of things that we can do cryptographically. Some of the other things that we can do is delegation. We can do time-limited delegation. We can say the signature is valid only from during this period, but actually build it into the signature itself instead of being a policy above the signature. Different kinds of use limitations. You can do things like say, this signature is only good if the transaction does not exceed $1 million. Or other kinds of content limitations where we can say this delegation is only good for signing a sub-project, not the prime project. So it can be like the development release, but not the public release. There's a lot of power when we can do internal depth, where we can have a variety of uses, but there's also this thing in the sense of external depth allows us to pass proofs. And this is something I think is a very powerful way of thinking about a lot of the future of blockchain is how does one system, one layer pass a proof to another layer that something has been accomplished from a transactional point of view. Oftentimes we actually do too much computation. We just need to be passing a proof. What are the requirements for smart signatures? They need to be composable. That means they're individual elements. Those individual elements need to be inspectable, which in the sense of that a human needs to be able to understand what's going on. But as importantly is that they need to be provable. There are new computational science approaches to doing provable components that we can basically go, oh, we really are certain about the security of the code that's in that. We have some runtime requirements. We want the smart signatures to be deterministic. We want them to be bounded. We want them to be efficient. A variety of different languages and approaches we can do this. There are functional languages like Forth, Lambda, which is kind of in the Lisp family. But there are other approaches. I would love to have a pull request to my paper on this from Ripple on crypto conditions. Obviously, Bitcoin, a lot of people you are familiar with. DEX, we're going to see as a demo in just a minute, or a quick talk in just a minute. We have a lot of open questions. How do you define context, and how do you deal with revocation, hardware devices, and then how do we deal with oracles? This is only an icebreaker. We need to evolve it. This came out of the last two rebooting Web of Trust. The next one is September 28th, 29th, and 30th in San Francisco. Weboftrust.info is the main site. GitHub Web of Trust info actually has the full paper and references to other things.
Okay, so now Peter will dive slightly deeper into the deterministic expressions. And next will be Wojtek Sai on blockchain IP right protection.
Howdy. So as Chris just mentioned, I've been working on something I'm calling DEX, which is a deterministic expressions language. It kind of looks a little like the Lambda calculus, but really the main thing we're really trying to do here is just create a way of specifying expressions that would return true if a signature is valid. And when you think about it, something like this, which is really just check a signature against pub key and so on for a message. Ultimately, that's what really would be baked into your software anyway. So really what we're trying to do here is move one level of abstraction to let you specify what kind of conditions you might need for your particular use case, which may be as simple as just a standard pub key, but you also might want to do a multisig where you have and Alice signs off on something, and Bob signs off on something. And what's interesting is that's very simple, but even something like that is, opens up a lot of possibilities. And we've seen this in Bitcoin with its multisig. You can also see things like OR conditions. So you might have, say, the idea of a release pub key, which can go sign any software release, and then maybe a dev pub key, which is only allowed to sign development builds. And you can build this in as, well, what's the definition of a valid software release? Well, it's either assigned by the release pub key or assigned by the dev pub key, but only if your build is marked debug. Simple, but nice improvement. And what's interesting with this is rather than hashing and committing to these kind of conditions as a hash of your entire script, if you start doing things with trees, you can start getting a bit clever. So I'd say, well, rather than serializing this whole thing, I'll serialize parts of the tree, and then what I'm trying to go convince you, hang on a second, this release build is valid. I don't actually need to give you all the other conditions. All you need to know is that the thing I've revealed to you as part of the signature process had the same hash. All this funny stuff about dev pub keys you don't need to know. You'll just see, oh yeah, there's some stuff behind that digest, and it's pruned away. You didn't need to evaluate it, but the OR, one branch of the OR checks out, and we're all good. And then the next kind of use case you then get is starting to get delegation, which, well, I could either have master pub key. I mean, if you're in OpenPGP, you know that you have a master pub key associated with your PGP key, but I might want to add more conditions to it later. So why don't I go check the signature on a binding signature and then evaluate this new sub-expression? And once you add this kind of primitive, well, you can start off with one key, sign new code as needed, and keep expanding the set of capabilities. Maybe that's my software release, in fact, and the sub-expression I sign is when I finally give the developers the ability to go and sign a sign a debug build. Oh, yeah, that's the last slide. So, very, very early stuff, but ultimately we're just trying to go and build some basic primitives. And of course, the flip side of this too is once you start having predicates, well, you might even go and define entire protocols in this. If this is valid, stay in the protocol, now it returns true, but I can't fit that in 3 minutes, so thank you.
Okay, so we'll be doing a table on topic on this once the breakouts.
Yeah, we will be doing breakout topic tables on every topic. Okay, so now blockchain IP right protection. And finally, the last, we will have two more topics. We will have Chris Tse talking about blockchain web testbed next, and then Manu. So be ready.
Oh no.
Let me take care of that.
Okay. Oh, it's the wrong file. It's on the. No, it's not. This is not the right one. Where's the file? No.
Okay, sorry for the, today I'd like to talk about the blockchain and IP right protections. And this is about a project that we do for the CCTV, which stands for China Central Television. And it's supposed to be a real-time tracking system for microphone usage. It's supposed to be a high throughput and low delay, and it's supposed to support 3.6 million people, concurrent users at the same time. And privacy and compliance are important. You have to be dependable, controllable, and elastic. And it also has the automated dispute resolutions in case of legal dispute. And CCTV plan to deploy 200 such systems in 5 years, and estimate that it will receive 140 million USD per year in 4 years. So that's the project scope. And this is the blockchain design. On the left upper corner is the European Banking Association come out with a proposal. And we look at it, we think it needs to be improved. So we divide the blockchain into ABC stand for account blockchain, and TBC stand for trading blockchain. So each of the blockchain will handle only one kind of functionality to make a system modular. And also since the load will be increasing, so we want to make the blockchain as like a cloud computing become elastic, can grow and shrink. And we are seeking for the multiple parties to collaborate on technical, business, and cultural matters. And CCTV has committed $23 million for each collaboration project. That's from the CCTV itself. And for example, in particular countries, if any partner like to partner with CCTV, and CCTV will put out 23 million USD for it. And then there will be an international advisory board. And basically we're doing the IP protection for foreign firms. And each firm will be displayed in a foreign country or in China, and with the blockchain protections. And so people ask me whether there will be a project in China on blockchains, and from my estimation, about $2 billion. I mean, these are all in USD, will be invested in blockchain. And CCTV itself has over $700 million USD planned to be invested in the next 5 years. And in a variety of domains, including energy, IP protection, education, and banking. And the Chinese journal, FC, has special issue on it. In October 26, Hangzhou, there's a CCTV event, and with a blockchain workshop. If any one of you are interested, you can come. And next month, we have W3C meetings at Beihang universities, and there will be a talk on blockchain. Okay, thank you.
Thank you. Okay, so now the Chris Tse and blockchain web testbed.
And while he's getting set up, how do I get that money?
Great. This came when we had 4 beers last night. And we were at, I think, Meat Hall or something. I think it's Meat with a D. I always thought it was like meat or something. It came from a conversation that I had with Doug, and basically said, you know, we're talking a lot about blockchain, but what about the web, right? So one way to do a testbed around the blockchain and the web is to essentially build browser plugins or use Cloud Wallet, use existing surface area of the web browser And the problem with that is that you don't get the full power of full clients if you want to put the actual blockchain and actually have storage on them. So we basically said, why don't we do this? Why don't we start with the web platform but give full capability for different blockchain provider, cloud wallet, light wallet, and kind of have a single test bed that we kind of try all of these ideas out. And one of the ideas I have is to say, why don't we use Chromium as the beginning? And that's a lot of work, right? So you have seen other wallet provider, Mist project from Ethereum using kind of Chromium as a starting point. But it turns out there's a really easy way to modularize and try different things out. GitHub has a project, which I think Microsoft's using for Visual Studio Code, and also Slack's using for the desktop app, whether you think it's fast enough for your daily work or not. It's called Electron. So essentially it's Chromium wrapped around Node.js. So that means that if you have a full client, you can kind of get C code onto that, wrap it around Node, and then provide a JavaScript API for a Slack-like application. You can also put a light client in it that doesn't do any validating and expose the same API. You can call it Cloud API so that you can get on board with a cloud wallet, whether it's a trusted version or untrusted version, or you can call a desktop API if you want to kind of communicate with the operating system. So if we can kind of agree that this general idea is a good idea, then we can experiment with a JavaScript API that is talking to the open web platform, right? So HTML, CSS, WebRTC written in web development language, whether you want to be completely vanilla and use whatever the W3C gives you, or you want to use a framework like React or Ember, doesn't really matter. We figure out how to kind of get those buttons and all the different organization. But I think it's worthwhile for us to see if we can kind of come together and say, all the experiments we're making has to touch the end user. They have to know what you're trying to do. So maybe we come together and say, let's create a blockchain web test bed, right, application. Let's put them in either W3C or a sponsor organization. And then anybody who has an idea, let's make it into the NPM module, like, and wrap either native code or light wrapper around your server-side API as Tendermint's doing. And so that's kind of what we're thinking. We can talk more about this as a table. I'll probably lead a table. If you're interested in this approach, let's see if we can start something here so we can demonstrate the value to the world in a visceral way. So that's...
Thank you so much. That's super interesting. Okay, Manu, you're the last one.
Got it.
And after Manu finishes his talk, I will ask every person who wants to lead a table. I'm not sure if every person who gave a lightning talk actually wants to lead a table, to come up to the stage here and give a summary in 5 words or less of what they want to lead the discussion on, okay?
I think what we should do is, you guys will all go on break. We'll have a conversation about all that, and then we'll come back and do the... Okay. Yeah, so you guys can talk amongst yourselves while we're sorting out what the tables are going to be. Yeah? Yeah, so... Sorry, to be clear, the presenters should still come up to us, but then all of us will decide what the tables are going to be. And then we'll reconvene and split up into tables.
All right. Sorry, I'm going to go ahead and get started. Hi. So the lightning talk is effectively on blockchains, specifically the bits that we think we can standardize. My name is Manu Sporny. I'm the CEO of a company called Digital Bazaar. We focus on next generation financial services technologies and identity technologies. Try full screen. Yes, please. So what we've been doing over the last year is taking a look at blockchain technologies. Specifically, we've looked at Bitcoin, Stellar, IPFS, Hashgraph. We've basically been taking a look at blockchain technologies and trying to see if there are any kind of commonalities between them. So the idea here is take the standard security and privacy principles that we take for granted, like confidentiality, non-repudiation, and see if each blockchain technology can achieve that by itself, or if it needs some help, if it needs some other thing to do that. That's fine. We can just keep going. So let me try and, where's the... So apologies for the complex slide on the right, but this is kind of a breakdown of the type of analysis that we've been doing. So this has to do with standard security principles. How does Bitcoin, Ethereum, Stellar, IPFS, Blockstack, Hashgraph, how do they do when you talk about things like data integrity or pseudonymity, things of that nature. And one of the things that analysis like this leads to is it helps you kind of figure out what the general bits that are common between all of these technologies are. So one example of this is this realization that, and I'm sure just about everyone in this room has come to the same realization, that a blockchain can be modeled as effectively a state machine plus events. It's really fundamentally a fairly simple thing, right? You start out in one state, you would apply an event like a storage event or a transaction, and your state machine goes into a second event, right? So this is an example of talking about blockchains in more general ways, and then seeing if we can take this general mechanism and create a standard or set of standards around them. So we've identified a number of components that are common to just about every decentralized blockchain-ish technology. And again, this is a conversation that we would like to have with the folks in this room. It's just a starting point. But we'd like to have a conversation about, is there a basic data model that's shareable across a good chunk of these blockchains? Just about every blockchain has a consensus algorithm of some point, right? So whether it's proof of work or the Stellar consensus protocol or hashgraph gossiping, there's this concept of a consensus algorithm that could be standardized in some way at W3C. Every blockchain stores data in a very specific way. Some of them use Merkle trees, others use Merkle-Patricia trees, others use standard linked lists. Every blockchain has a set of ways that it signs its data, right? So we've got signature formats already, Jose, linked data signatures, hierarchical deterministic keys are something that's kind of interesting to try and standardize. The smarter signatures stuff is really interesting. That's a standardization target. Proof of publication. So these are all kind of interesting building blocks of blockchains and potential standardization targets. Clearly, we're at the W3C talking. It would be good for us to talk about what the protocol is to access these things over the web. Is that something that could be standardized? So there's this proposal that we have called Flex Ledger. It's very hand-wavy, but it's an attempt to try and express each one of these standardizable blocks and components in a way that is designed to go through like the W3C or the IETF standardization process. So the breakout session that I'd like to have a discussion with folks in this room about has to do with what are the component pieces that we think we can standardize at W3C. Let's get that laundry list started. Thank you. Thanks.
So this will also be part of the topics that we're talking about this afternoon. So this could be this breakout could be a good lead-in to what we're going to be talking about after this afternoon. And we actually have one. It was my fault. I omitted somebody from the list. We have Jutta Steiner from talking about building infrastructure for the future decentralized web, and then we're going to take the break. And we might have Juan Bennett giving a last-minute talk. Oh, there he is. So 2 more talks. I'm sorry. IPFS and friends.
Okay, so yeah, my name is Jutta. This is Tomek. We both work for a company called Escor that's like rooted in the Ethereum ecosystem, so to speak. So Gavin, who's one of the co-founders, wrote the first working implementation of Ethereum and the formal specification. I myself ran the security audit prior to launch. So, but now, last fall, we started a company called Escore, and we are lucky to get people like Tomek as part of the team. What I wanted to do is share with you kind of the vision that we have for the future web and how blockchains and other decentralized technologies play a role in that vision, but then also show you a bit what we've done to make this vision a reality. So that's what Tomek has been working on. So what we do at Escore is building the infrastructure for the future decentralized web. That's what we usually do, unless we get sidetracked by the DAO. So the last weeks were a bit more about thinking about the soft and hard fork, which we hopefully soon get fixed. I mean, but now I think we should add a few more characters, like a hard fork that maybe eats the DAO or something like that, and a few more fires of the white hat, started by the white hat attackers. Anyway, yeah, so, but it also showed that kind of decentralized is maybe not the most important thing, but we should rather think about like that we're building like a peer-to-peer secure serverless web, or but I mean, I think it showed also that why it's so hard to communicate to people why decentralized is such an important notion, because it might, I mean, there's no intrinsic value in being decentralized, right? I mean, there's an intrinsic value of being utilized and secure by people, but yeah. Oh, sorry, okay, I didn't realize that. Okay, so then let me jump a bit. So this is kind of a bit of how we see the architecture. So blockchain is just one part of it, complemented by decentralized encrypted information publication systems and Whisper, but also the UI part, and this is where W3C, I guess, comes in. Secure transaction signing technologies and identity management are things we've been working on, and Tomek is going to demo that. So if you want to download it, it's just basically two things. You go to our website, install our Parity client, and also install the Chromium browser. And now.
So what we built right now is you download the node, you are running the node on your computer, and on Ethereum you have your backend, but you build your front-end application on your computer. Yeah, it's so this is what you see. Maybe you don't see the URL right there, but it's localhost 8080. And of course, if we run many applications, then there is a problem of separating local storage or other things. So we solve it right now by using proxy pack files. And then let's go to the wallet. And let's go to the transaction already. So over there. So when you send a transaction, this is the moment when you have to use your private key. The private keys are stored on your node, but they are password protected. So when we send, the app can ask you about the password, but then it might memorize the password. So what we built right now is a separate context in Chrome extension that asks you for the password. And this is the only place that you have to provide your password and you have to trust. And we're run out of time, but we can continue the discussion later.
You will be able to demo it later during the day, and this was more to show what you want to discuss, not to really demo your product.
Maybe like a short description of what we want to discuss is what is the browser responsibility and the browser role in this decentralized environment.
Great.
Thank you.
Yeah, great. Thank you. Okay. Juan, I've PFS and Fran.
That's right. Is this good?
Hey everyone, how's it going? So I wanted to tell you stuff about IPFS, but I won't have time. It's more important to tell you about other things. So the IPFS project is a large endeavor, and it has a lot of sub-projects and sub-protocols. Some of you might be familiar with these, the multi-formats. These are self-describing values for the purposes of protocol agility, interoperability across protocols, and to avoid lock-in. This is one of these things that prevents people from making bad decisions, or rather, things that look like good decisions today will certainly be bad decisions tomorrow. So ideally, you want to create and use formats that allow you to evolve the protocol over time, right? So a pretty simple example is, what do you do with cryptographic hashes, right? So you might have run across a situation like this when you have 4 different hashes that are all the same length that happen to be coming from very different functions. And you, when looking at the value, have no idea what those functions are. This happens way too often. It happens for a variety of reasons. People need to move things, need to evolve things. People choose better, faster hash functions that are created later. Different hash functions are chosen for different architectures. People are worried about security, so they upgrade. Lots of reasons. The problem is that the values don't self-describe, and there's usually no way to then inject more code to pass the values out of band when it wasn't designed explicitly at the beginning. Think about Git and what Git now will have to do if they want to switch from SHA-1 to SHA-2 to V6. So the trivial solution is you actually prefix the value itself with some encoding. And this is not new. There's other protocols that have done this in the past. But what is new about multi-hash is to make sure that the value is part of the digest and not a different thing, meaning it should be encodable the exact same way as the value. So this is in hex, and the value that is part of the self-describing thing should be part of this. So it's a pretty simple format. You just have some function code. You keep a table. You have some notion of the length, because as I showed before here, these are all 256-bit hashes. That means that some of them have been truncated. So you want to take that kind of stuff into account. So multi-hash specifically is a self-describing format. The codes are in the value itself. It's as small as possible. Have no assumptions about reality, like make no assumptions about what the hash function that you're using now or using tomorrow is going to be, and so on. It has a bunch of implementations in a bunch of different languages. People are already adopting it for various things. And like multi-hash, there's a whole bunch of other protocols. We call these like multi-formats. They're usable by a whole bunch of distributed systems. They're coming out of the IPFS project, but they're usable by a bunch of things. So these are things that are, an example is multi-address that shows these different ways of expressing addresses across different transports and so on. And these are, the emphasis is to get both human readability in one version of the format and then have a binary packed version that is very efficient. So I won't go through all of these because there's no time, but the goal here is to create these very small formats that are usable across these systems, and you can find agreement across them without having to lock yourself in. Cool. The other thing I wanted to talk about is IPLD, and this is, I think, pretty important. So what do all these systems have in common? Things like Plan 9, Bitcoin, Ethereum, torrents, Git, and so on. They all are distributed data structures, authenticated data structures, hash-linked data structures. So you can think of IPFS as a forest of hash-linked data structures, right? So the goal of IPFS is to build a distributed system that allows you to move around these different kinds of data structures without worrying about what specific use case they implement, right? The file system part, the representing files and directories and so on, is just one application of the whole of the thing, right? So IPLD is a format for creating, think of it as an intermediary thin waist for all these different hash chain based distributed systems, right? So you can think of addressing different kinds of data structures across these different hash-linked distributed systems with the same format. And the idea of IPLD is to try and provide something that's super simple that already builds on what people expect out of the web, using things that serialization standards that people already use, have some canonical way of expressing the object so that everyone can agree on how to hash them without having to create side standards for this. Create a way of pathing across these objects so that it's reasonable to traverse from one object to another. So the data model of IPLD is really simple. You can think of the simple data model that people are used to with JSON or YAML or things like that, and use that. You get lists, dictionaries, integers. Integers are not in JSON, but there are ways to put integers in JSON. And the idea is to pack it into a nice binary format and express it to users in JSON, YAML, or whatever they prefer to see, and then have a way of linking between these objects, right? So we use CBOR as one of the representations, but the point is to create one-to-one mappings between these so that it's always extremely clear how you move from one to the other. So IPLD is in use by a whole bunch of different systems already, and it is ready for standardization. We're pretty happy with where it's at. There's some extensions that we'll be adding over time, but this is one of those candidates that could be really good to potentially produce the standards here. And it is meant to, it's one of those things that the IPFS project is producing for blockchains, right? And so to give you a flavor of what the format looks like, and I will go through this with other people in time, but you can think of like just these data structures that start linking to each other, and you have like these hash links that you're resolving through. And the point is to be able to have pathing across these hash links, so that imagine in a blockchain you would be able to refer to a parent block and then walk back the history. Like say, you have some hash and then you say /parent and you move into the parent of the block. Then you say /transactions and you move down that and slash into one, and you can address everything with random access. Cool. So this format is probably one of the more interesting things we have to contribute to the whole W3C workshop on blockchains. And I'll do a longer tutorial and I'll send it out as a video. Cool. Thanks.
Okay, folks, how about we give you, first off, a big hand for all of the lightning talks. I know it was drinking from the fire hose, but I was blown away. Great stuff. Why don't you take 10 minutes and go talk amongst yourselves. Everybody who would like to run a topic table, come up here. And we'll sort out what the topic tables are, and then we'll tell you guys once we reconvene. Oh, shit. Were you going to do a presentation?
It doesn't matter. I just wondered what is that together? Oh, yeah. Yeah, maybe later. Doesn't matter when. Okay. Yeah. No, don't worry about it. I forgot. My fault. Okay. A way to judge interest. That's one of my things. It's like,
just 1 second. Chris, you're running out. Before everybody splits off, if anybody liked Chris's idea, Chris had this idea of the test bed, sort of a prototype test bed where we can test it. He has to run actually because planes. But if anybody's interested in that, while we're trying to organize this, come over here and talk to Chris. We'll start this conversation and we will find a way to continue it. But I want you to make sure that anybody who's interested in that, come talk to Chris, because I think this is a really amazing idea. So everybody else is on a break. Okay, guys. So we'll give you. Fantastic. Well, sorry, not just W3C. Of all of you, he's the only one who looks primitive. That's shaggy.
That's not really.
Why are we squeezing it?
We're not. It's just that we. Okay, guys, let's huddle up. Everybody, let's huddle up over here where we have room.
So we have IoT.
No, we already did it.
Oh, really? Oh, shoot.
Actually, probably the more tables, the better, because that means that we can more. Yeah, because people can all talk, right?
So the community group, do you feel like there is any kind of overlap here with community group and
No. That's
I'm just
no.
trying to get a list of all the
Okay. So you're covered, IoT is covered.
Did we talk about IoT yesterday?
No.
Was there a breakout on IoT? We can propose it.
Okay, you're with Manners.
Just a second. Chris, say. You guys come over here. Okay, let's have one conversation, everybody. Let's have one conversation. Sorry. Per topic, yeah. So,
Three people per topic. One person per topic. So, you're with Manners?
just a second. Let her run this.
Okay. So I still need this.
But everybody, we're listening to her right now.
Okay. So we have IoT. Does anyone want to combine with IoT over 10? No.
Okay.
Great. We have the community group and harmonizing the community group. Anyone want to combine with that?
various communities that are.
No. There is a structure at W3C called a community group, and they run that. And so you could have a table, but I don't think you're going to get a lot of people. I think most people want to more talk about technical stuff. You can have a table, but I think you might want to combine with something else.
Cool. You wanted to talk legal?
Yeah. I think there's definitely. Is anybody else legal? Daza.
Gaza!
Jeff, come here. Okay.
Okay. So you're going to run the legal and probably the answer is wrong.
I'm not sure. So, yeah, that corner people here seems
No, that's separate. Browsers role. I think that kind of.
Yeah, that's what I was asking. No, it's so there's the
okay.
High level DOM APIs. How would you
we're all
resolve
in a different direction.
Okay, you two. You two get together and figure out what the five word summary is. Figure out what your 5-word summary is. Your summary is legal. That's good enough. Okay. And maybe Dex and
Okay, so get together with those people and figure out your topic.
Yeah, we got it.
Okay.
Hey,
You get together.
Yeah. Do you guys?
You
wanna
guys,
do
you guys split off and come back to us with a proposal. If
I mean, I think the conversation should be.
and then come back whether you decide to or not.
Yeah, I think we got 5 words. Basically, the UX. UI.
No. Right now we're clustering, and you guys come back to us with 5 words at the end. Thanks. Sorry. Security and trust. Security and trust. Security and trust. Anybody else want? Okay. Okay.
What do you mean by well, then figure if you're.
Do you guys already have? Are there any?
Description of your topic.
Okay, we talked a lot about that yesterday. Unfortunately, I apologize. I really liked your presentation, by the way.
What is?
Okay. Chris is going to.
You don't have to sit us in here.
No, you're fine.
You're fine.
Thank you.
I just need you to.
Okay, I see.
Okay, so how many?
Great. So legal IP protection. Great.
5, 6.
Think of a 5 words description of that. Okay.
We have 7 or 8 things.
That's perfect. 7 is good. 7. We haven't decided yet if they are.
Did you
Uh,
figure out?
Yeah, he can represent.
Okay.
I want to pull the two of you aside for a second. Can you get everybody like? Love this idea. Great. You and I were talking about this stuff. You can't just let this go out. Right? And we tried it. I'm happy to both tried it. From a technical point of view, from an organizational point of view, I might be able to help coordinate. Let me find. I can code. Okay, I can code. But I'm just not good at it.
And sorry, I didn't.
Obviously, we get updates, but maybe there's a community group around this that can consolidate the discussion. Okay. So what we're going to do is we're going to let's just count on your commitment. I'm going to commit 3. I hear that you nodding too. Okay. Can I just try to figure that out? You know what? Come get me before. I'm going to email the two of you because I know your email. Oh, that's right. You're Robbie. You're Robbie. Okay, yes. Sorry. I'm sorry. All Indian people look alike. Well, you know so, oh, look at us. Aren't we? Okay. Here's what we're going to do. I'm going to email 3 of you. Yeah. And we're going to pull this together and get the thing. We're going to build an infrastructure. Anybody else who thinks it's involved in each, we'll propagate it out. Yes. Yeah.
That makes a lot of sense. And I think, you have this kind of form the decision of like, do we continue with this approach or do you want to do
Well, so I think that using Electron is probably it's a huge lever.
Yeah.
It gives you a lot of efficiency. And writing to node, I need to get back to
stuff, but this is the plan.
Yeah.
It's good. Sometime today, I will email them and we will. And I guess maybe Chris. Thank you so much.
Yeah, we can be done, but
And he's gonna go in. He's gonna converge into
I'm gonna do the same thing again. 'Cause... Hello, everybody. Hello, 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 hello. Start gathering again. I need the people who will be leading the topic tables to come up here. You should know who is leading. One person per topic. One person per topic. One person per topic. I believe we should have 7 people up here. 1, 2, 3, 4, 5, 6 is.
Any other topic tables?
No, okay. Okay. So now I need you to really focus because we will be presenting the topic tables and you will figure out which topic table you are joining. And we'll do the same thing as we did yesterday. You'll have a bit over an hour or probably an hour to discuss the topic as yesterday. And there will be report backs just before lunch. So we'll start from here.
About 40 minutes.
Yeah, right. And then report backs.
Well, it depends on how we want to do it, but we're going to try to tighten things up.
Okay. Anyway, starting from the right.
So a legal group, anything connecting the legal group, anything connecting the smart contract and automation environment with the legal environment.
We'll be discussing the top-level DOM APIs and also how the browser can visually represent various parts of the blockchain, like identity, other things. And there's a demo.
Blockchain standardization proposals. So if you think that there is something that we could start standardization on, what's the component you want to standardize? We're going to be discussing that.
Interoperability protocols and primitives. So Lightning, Interledger, crypto conditions, DEX, smart signatures. That we may fork out. We may decide to go primitives and protocols. It depends on who's working on the table.
Okay, at my table, so what kind of security evaluation on the trust is needed? Will be discussed.
IoT and blockchain, and it'll also, the discussion will border on more compute and data at the edge.
Okay, so is everybody clear on which?
No, I see some people shaking heads. What's not clear?
Okay, legal. What was it? Stuff the browser does. Stuff the browser does. What makes sense to standardize? Interoperability. I have a strong voice.
No, because there's.
Okay. Interoperability, security, IoT.
Interop protocols and primitives.
Okay. Security, IoT. Is that clear now? Okay. So these faces and people that have those faces will sit at different tables and you should join them. And you have 30 seconds to do that. So stand up and run.
You guys should spread out so there's room to talk.
Yeah.
It's not going to happen in 30 seconds. But that was a good.
That's right.
Once the tables are.
Yeah, but okay.
Legal,
No,
of course.
somehow that didn't get enough of the primitives.
We're going to be talking about primitives all up. Oh yeah, that's. I mean, that's well. I mean, there's too much. Not too much. There's two different tables that are you talking about, sort of like browser type features. Did you feel like that's not? Mono's kind of driving the primitives though. It's not the only one at the table. Did you feel like there's something else that needs to be?
I heard about 3 different talks that didn't really resolve into tables.